Polarity check for speakers, microphones, and amplifiers. A typical sound system consists of microphones, audio amplifiers, and speakers. All these components have a polarity. Sound waves are generated by fluctuations of air pressure. A positive pressure before the microphone will push the microphone diaphragm inward and produce a positive potential at its positive terminal. A negative pressure before the microphone will pull the microphone diaphragm outward and produce a negative potential at its positive terminal. An amplifier can be non-inverting and inverting. For a non-inverting amplifier, a positive input pulse will result in a positive output pulse and vice versa. On the contrary, for an inverting amplifier, a positive input pulse will result in a negative output pulse and vice versa. As for the polarity of a speaker, when a positive voltage is applied to the positive terminal of the speaker, the cone of the speaker will move outward, producing a positive pressure in its front. When a negative voltage is applied to the positive terminal of the speaker, the cone of the speaker will move inward, producing a negative pressure in its front. If the microphone, non-inverting amplifier, and speaker are connected with correct polarities, then a positive pressure before the microphone would produce a positive pressure before the speaker. In this case, we say that the absolute polarity is maintained. If any one of the three components has its polarity inverted, for example, the speaker, then a positive pressure before the microphone would produce a negative pressure before the speaker. In this case, we say that the absolute polarity is inverted. The human auditory system is not sensitive to absolute polarity except for very low frequency and high impulse sounds, such as percussion. Thus maintaining the absolute polarity is generally not a priority in practice, although it is absolutely good if it is achieved. It is the relative polarity that has significant impact on the perceived sound when multiple microphones, amplifiers, and speakers are used. For sound reproduction, maintaining relative polarity means that all speakers are polarized the same as one another, without regard as to whether they have a correct absolute polarity. The reproduced sound field will be messed up if the speakers are out of phase. For example, if two speakers are emitting the same tone, and one of them is in a state of inverted polarity, those tones, when combined at a given spatial point, will cancel each other. This effect is stronger at lower frequencies and will result in loss of bass and destroy the original stereo imaging. Similarly, maintaining the relative polarity of microphones is of great importance for sound recording. For example, when two microphones are used to record a single sound source, it is imperative that they respond to a positive pressure on their diaphragms in the same way. If the polarity of one of the microphones is reversed, the tone will become very thin and lack bass when the two outputs are mixed together. Even if the microphones are panned hard left and right for a stereo effect, if their polarity is not consistent, the sound will appear to be unfocused and vague, and difficult to localize in the stereo sound field. Polarity check for a speaker like this is simple. Just connect the speaker to a battery momentarily and observe the movement of the speaker cone. Now, the gray wire is connected to the negative of the battery and the pink wire is connected to the positive of the battery. The speaker cone moves outward. Therefore, the pink wire is connected to the positive terminal of the speaker. Let's reverse the connection. Now, the gray wire is connected to the positive of the battery and the pink wire is connected to the negative of the battery. The speaker cone moves inward. This method, however, is not practical if the movement of the speaker is not discernible, such as the cases of tweeters. Or cannot be seen, such as the cases of horns, or speakers already sealed inside a speaker box. Here, we introduce a polarity test method using the software multi-instrument, which can be downloaded from our website at www.virtins.com or www.multiinstrument.com. We will use its oscilloscope and signal generator functions. The hardware is a computer with a sound card. The speaker under test is connected to the left output channel of the sound card. The signal generator will generate a polarity test signal and output it through the speaker under test. A microphone is connected to the left input channel of the sound card. It is placed right before the speaker to capture the test signal. The polarity test signal can also be generated through CD or memory stick and the like. Let's start the experiment. Launch multi-instrument. Click the polarity button in the hot panel setting toolbar to load the polarity test setting. Start the signal generator. Put the microphone right before the speaker under test. Note that the polarity of the speaker can be determined in two ways. First, the color of the window indicates the polarity. Green means positive, red means negative, and white means that the quality of the polarity test signal is not good enough, in which case the volume of the speaker should be increased to make it distinct from the background noise. The microphone gain may also need to be adjusted. However, the captured signal should not be clipped. That is, the recording peak level at the upper right corner of the screen should not reach 100%. If I move the microphone away from the speaker, the quality of the captured test signal will drop. The polarity color will eventually become white. The polarity of the speaker can also be determined by checking the captured pulses. Let's put back the microphone, and examine the captured pulses closely. As indicated by the color, the current polarity is negative. The captured pulses always start from negative as well. Now, I swap the two wires connecting to the speaker to change the polarity. The polarity color changes to green accordingly. The captured pulses start from positive now. Zoom in to take a closer look. Now, let's do another experiment. We need to burn the polarity test signal here onto a CD and test the speaker polarity consistency in a car. On the signal generator panel, uncheck the loop flag. In the duration edit box, enter 10 seconds. Click the save button and save it as a 10-second mono wave file. Burn it onto a CD. Now we will use our product RTA168 to measure the speaker polarity in a car. One good feature of RTA168 is that it is able to measure the absolute polarity of a speaker. Insert the test CD into the CD player. Adjust the volume so that it is well above the background noise. Put the measurement microphone close to the front right speaker. As shown, its absolute polarity is positive. Put the measurement microphone close to the front left speaker. Its absolute polarity is also positive. Now, put the measurement microphone close to the rear left speaker. Its absolute polarity is still positive. Shift the measurement microphone to the rear right speaker. Its absolute polarity is positive. So we can conclude the four speakers are in phase and the absolute polarity of the car sound system is maintained.
Verdon's technology. Turn a PC into multiple virtual instruments.